Here's problem number 9 from section 3.8. It says that we have to assume that there's a particle moving to position x for some given time t, and they ask us, well, what's the velocity at some particular time, and in this case when time is equal to 3. So in order to find velocity, the velocity is going to be the derivative with respect to t of x, and I can write it in either of these two ways. That's a t. And then I say, well, what is the derivative of this function? Well, the derivative of arc sine is 1 over 1 minus the square of the inside function, which we usually call u, and so it's going to be t over 4 quantity squared, and then of course we have a chain rule where we multiply all of this by 4. Let's see if we can clean that up a little bit. Underneath the square root we have 1 minus t squared over 16, and then this is all 1 times 1 over 4. If I find a common denominator, I'll end up with 16 minus t squared over 16, sorry, lost the top part of that fraction, times 1/4, which is going to end up getting me, there's a 16 in the bottom and it's a perfect square, so I'm going to factor out that, and so I end up with 1 over, there's the square root of 16 minus t squared, and then over here that 1/16 I pull out becomes a 1/4. Here's another 4. There's a 1/4 and a 4. Those two cancel out, and so I'm left with a velocity of 1 over the square root of 16 minus t squared. So that's what v of t is at 3. This is going to end up being 1 over 16 minus 3 squared, which is equal to 1 over the square root of 16 minus 9, which is equal to 1 over the square root of 7, which is more commonly written as root 7 over 7.